A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. We shall be starting in a couple of moments. So, good evening to all of you, and welcome to the final module for climatology, that is climatic classification, where we get to study about the climate and the different climatic types experienced across the world. So this is basically a part again of your world geography. In geomorphology also we had covered world geography by studying about the various different geographical features and geomorphological processes across the world. Something similar we will do here as well when we carry out the study of the different types of climatic conditions across the world. Now, this is a portion which UPSC in general studies does not ask in the mains examination. This is a portion that UPSC generally asks for general studies in the prelims only. Okay, so here under this we are going to study about the Köppen's classification of climate across the world and the various different codes included by Köppen in order to classify and give an idea about the different types of climatic conditions which are in existence. So here what is relevant for your prelims is basically the basics when we talk about basic climatic features of certain types. For example, equatorial climate. Okay. Then monsoonal form of climate we have already covered. Then you have British form of climate, British type, Mediterranean type. Then you have savanna type. And then also you have the China type. Okay. These are the only climatic types and the only climatic conditions that you should be focusing upon. Even though we are going to cover the other areas also, but I would suggest to you that restrict your preparation for your prelims mostly only in these areas. Okay. Now, let us initiate with this discussion, and this particular chapter is going to be theoretical, quite significantly theoretical. This particular chapter is going to be hectic as well for many of you. You'll find it incredibly difficult, and there is no harm in accepting that it is incredibly difficult to get in terms with this various different terminologies, etc. And it is very, very theoretical. So in order to gain a complete control over this chapter, I would rather suggest to you that approach this chapter only after you are very well sure and very well versed with, for example, factors such as the permanent wind systems, the pressure belts, the shifting of the pressure belts, right? And due to the shifting of the pressure belts, how certain areas they start experiencing onshore winds and certain regions they start experiencing offshore wind conditions. So those particular factors you have to pay significant attention to. Okay, once you have a quite a good grasp in order to understand that in which season which particular area experiences onshore, in which particular season any area experiences offshore wind system, and where is it that temperate cyclones can happen, where is it that tropical cyclones can happen. That means once your concept of climatology is well and clearly understood, after that if you approach this chapter, it will be beneficial for you, and then it will be approachable and easier as well. Okay, so here We start with that aspect of climatic classification, and basically we initiate the discussion with the Köppen's classification. For GS, Köppen's classification is all that is required to be studied, that is required to be understood. Now, when we talk about Köppen's classification of climate, Köppen, Vladimir Köppen, basically put forward or postulated this classification in the 1900s, around early 1900s. Now, since that point of time, no, Gaurav, from this topic, you don't expect a mains type question. No. At least in general studies, you don't get. In optional, you get direct questions from this, but not in GS. So, here, ever since you had mankind basically being able to discover different parts of the planet, mankind was always curious in order to understand what is the climate experienced in different parts of the world. In fact, that curiosity about climate goes back to the time of Aristotle. Now, Aristotle, in his own times, had given that classification of climate where, and the Greeks followed it for a long period of time, where the planet was classified into the various different regions. So you had the tropics were understood to be very, very hot, significantly hot. So much so that the Greeks thought that in these regions close to equator, nobody can possibly survive because the temperature is so high, it will be impossible for the human habitation. Obviously, we all survive in that region. So this was named as, at that point of time, as torrid zone. Okay. Then the temperate areas beyond that, they were referred to as the temperate zones. This was thought to be the perfect conditions for human habitation. And then they also had discovered by that point of time, think about the endeavor of human discovery and the spirit behind it. So, thousands of years back, basically, they had discovered that if you go further north, then you come across areas which are permanently frozen throughout the year. So they named those places as the frigid zone. So this was the early classification that was used. And that classification did exist for almost close to 1000 and 1500 years. But then, over a period of time, obviously, much greater amount of analysis, much greater amount of information came into existence about various different climate types across the world. Now, in the 1800s and by the late 1800s, significant amount of scientific work and discovery had been done, had been carried out in basically, excuse me, significant amount of work and discoveries had been carried out in almost all the areas of botany and so on. So, you had a French biologist and botanist with the name Candolle. Now, Candolle in the 1870s came out with an entire encyclopedia of sorts, talking about the various different types of plants and natural vegetation that you find across the entirety of the globe. It was a kind of a complete encyclopedia. Now, Vladimir Koppen, being the smart guy that he was, he basically thought that plants in an area, they grow, and the different types of plants, they are dependent on what? They are dependent on the amount of rainfall received and the temperature experienced, isn't it? So he thought that if I have the classification of plants ahead of me, I can utilize this in order to explain the classification of climate as well. Because different plant types will have different requirement of rainfall, different requirement of temperature. So I can go ahead with this and classify the climate as well. So basically, with the help of that data, the encyclopedia, which was compiled by Candolle, Köppen came up with his own climatic classification. So, this was based on the amount of rainfall and also temperature experienced in any area, right? Because the natural vegetation would be dependent on this. At least that is what Köppen had thought. Later on, it was understood that even the rate of evaporation, that is also responsible for the type of plants that we see. It is not only always dependent on the amount of rainfall received. If, let's suppose, in an area the evaporation rate is very high, then what do? So that is why here this Köppen classification was later modified by his pupils. You then had Köppen, Geiger, Pohl. So different types of classifications came ahead, and then you had Trevartha, Thorndike. All of them came up with their own different set of classifications later on. But nonetheless, for GS, you just have to be aware of the basic Köppen classification. Now, what Köppen did, he divided the climatic zones or entirety of the planet into various climatic zones. And he used capital letters, alphabets, in order to denote different type of climatic conditions. So he used the capital letters: A, very close to equator, the equatorial region; B, the subtropical highs, which have deserts around them; C, the temperate areas across the planet, where you have moderate kind of climate; D, regions such as Canada, Siberia, which experience extremity of climate; E, the polar regions, the frigid type of climate. And he also denoted another letter, H. H was used as a letter to indicate highland type of climate, because Köppen was well aware that despite the regions being at the same latitude, few of the areas experienced very low temperature because of the fact that they were present at an altitude. They were present at an highland. So H was indicative of highland type of climate. Climate dependent on altitude, represented the unique conditions experienced in altitudes. A would represent the regions of equatorial climate. B would represent the dry areas, the deserts, generally that you find in subtropical high pressure region. So this would be the desert areas. Dry areas. C would represent temperate, moderate climate. D would represent the regions such as Canada, Siberia, etc., that is in the interior of the continents, which would experience very cold winter, but summer also would be around 10 degrees, 12 degrees Celsius. That is something which you experienced in D. E would experience, or E would represent polar type of climate. Okay. So that was his basic methodology, which was used to carry forward the classification of climate across the world. So here is a brief gist of it. A type. A type represents humid tropical climate, where you have warm and moist conditions which are prevalent throughout the year. And the mean annual temperature is always going to be above 18 degrees Celsius. Annual average temperature is always going to be above 18 or higher than 18 degrees Celsius, means the temperature in general is higher in that area. B type, dry climate, represents both cold and hot deserts. desert areas. Then C type, where you have mild winters. Average temperature, mild winters in the sense you have temperate kind of climate, where you will observe that average temperature of the coldest and the warmest month will be between around 8 to 18 and 22 degrees Celsius, where it will neither be very cold nor will it be very, very hot. Okay, so neither very cold nor very hot. Very cold nor very hot. This was the temperate region that the Greeks thought about to be the ideal condition for human habitation to happen. And then you had the D type. D type, average temperature of the coldest and the warmest months being roughly around -3, -5, -6, and above 10 degrees Celsius for the summer. So summer would not be very hot, but winters would be drastically cold. And then E type is the polar climate. But he was also clear that at the region, for example, A type represents equatorial climate. But all the regions at equator don't have the same climatic conditions, right? Different areas around the region of equator, they will have different climatic conditions. It is not as if you will have a uniform climate across all these. Maybe some regions will receive rainfall annually. Maybe certain areas will receive rainfall only during the monsoon months. Maybe certain areas will receive rainfall only during the winter months. Similarly, maybe in the temperate region, some areas will have higher temperature, certain areas will have lower temperature. So, along with these capital letters, Köppen also made use of the small alphabets, the small letter alphabets, that is F, M, W, and S. And they would basically be indicative of the amount of rainfall which is observed, which is basically received in different parts of the year. For example, F would indicate when it is raining throughout the year, no dry season. So that means you have rains throughout the year. Okay, that is what would be denoted by F. So raining throughout the year, every day, on a daily basis, if it is raining, that is F. Then M. M is the monsoon climate, where you will receive rainfall only for those months of the year. That is, for those monsoon months, 3 to 4 months. Generally, during the summer season is when the monsoon season comes in. So that is when you would receive the monsoon rainfall. So rains received primarily during monsoons. W would mean winter dry. So only summer rainfall. Rains only in summer. And then you also had S, which would represent the rainfall only in winter. Okay. Only in winter. Right. So this was used to depict the type of variation that you experience in rainfall received in different parts across the same climatic zones as well. Now, furthermore, A, B, C, and D was also added on in order to have a delineation in terms of temperature, which areas will receive higher temperature, which areas will experience a slightly lower temperature. For that, A, B, C, and D was also significantly put to use. Now, let us take a look at this entire representation. Let us approach each one of these. What is A type? What is B type? C, D, E type? Let us approach each one of these and let us try to get through the basic properties, the basic features that you observe in this. So when we talk about, let's suppose, the classification of it, the easiest way to recall or remember it is the fact that A type of climate would be restricted very close to the region of equator. As you move away from equator, you come across the desertified or subtropical high pressure region, which generally encompasses deserts. So that would be B type, slightly away from it. Slightly away as you move ahead, you will get the C type, D type, and E type in the polar area. Okay. So one by one, let us take a look at each one of them. Starting with the A type. Now, A type basically represents the tropical humid climates. Okay, the tropical humid climates. Tropical means in the region of the tropics, means the average annual temperature is very high. So when we talk about tropical here, average annual temperature is high. Humid, the moisture availability in the form of rainfall is also significant. And that is the tropical humid climate, generally experienced between the tropics, Tropic of Cancer to the north and Tropic of Capricorn in the southern hemisphere. So they exist between the Tropic of Cancer and the Tropic of Capricorn. And sun basically being overhead in between these areas, that is between the summer solstice and the winter solstice, the sun will remain between the Tropic of Cancer and Capricorn respectively, isn't it? So that is why here the presence of ITCZ means the climate becomes hot and humid. So ITCZ causes rains, brings rainfall. Okay. And then annual range of temperature is very low, whereas the annual rainfall is high. Annual range of temperature means what? The difference in temperature between the summer and the winter months. That is what represents the annual range of temperature. So when you talk about annual, so you have annual range and you have diurnal range, right? So annual range of temperature represents the difference in temperature between the summer and the winter. Diurnal range of temperature represents the difference in temperature between the day and night time. So this represents difference of temperature between summers and different seasons rather, seasons is minimal. Means consistent temperature throughout the year. Okay, that is what is meant by it. So you have in the tropics generally consistent temperature which is experienced throughout the year. Okay, now here in the tropics, the type of climatic conditions that you experience are or can be classified into three types. You have the AF, AM, and AW. AF, tropical wet climate, means rainfall throughout the year. Rains through the year. Right. AM, rainfall only during the monsoon season. Many parts of our country will experience AM type of climate. That is, rainfall only during or major amount of rainfall is observed during the monsoon season. And AW, that is winter dry. So rains only during summer. Rains only during summer. So this is also what is referred to as savanna type of climate. Savanna type of climate, where generally you have grasses, grasslands in general, tropical grasslands, which are present also in India. For example, in parts of Karnataka, in Telangana, in parts of Maharashtra also, you will find the presence of the tropical grassland. So that is a feature of this, where the rainy season or the time or the amount or the duration for which you receive rainfall, that duration is very, very less. So that is basically the classification. Let us take a look at each one of them along with the weather pattern that is observed. So starting with the AF. AF is the tropical wet climate. Okay. So when we talk about AF here, I want you to observe this particular chart of Iquitos in Peru, which is around the region of equator itself. So here, AF means what? Rains throughout the year, isn't it? So here, if you observe, then in the different months, Jan, Feb, March, April, May, June, July, August, September, October, November, December, in all these months, rainfall is received. To some extent or the other, rainfall is received in all throughout the year. So observe, every month you receive close to around 25 to 30 centimeter of rainfall. Means 1 centimeter, almost 1 centimeter of rainfall almost on a daily basis. And observe the temperature. Temperature is largely consistent. The temperature is largely consistent. So the annual variation in temperature is almost minimal. There is not great variation in temperature as is experienced. Okay. Now here you will find the growth of tropical evergreen rainforests, right? So that is something which you observe in this case. So which are the areas in the region around Brazil? You have the Amazon rainforests. In the region in Africa, you have the Congo rainforests. Then in Asia, you have the region around Indonesia, Java, Sumatra. There also you have tropical rainforests. So all these are found in this area. So precipitation occurs all the year round, and variation in temperature in between different seasons is less than 3 degrees Celsius. You don't have much greater variation between the summer and the winter, so that is less than 3 degrees Celsius. Humidity is extremely high, and the surface temperature results in formation of cumulus and cumulonimbus clouds in the early afternoon on a daily basis. This results in high rainfall on a daily basis. Okay, so daily rainfall occurrence of rains. This is, by the way, what is also referred to as the equatorial type of climate, where the average annual temperature is also high and daily rainfall due to process of convection. Equatorial type of climate. Okay. Now, after this, here, because the rainfall available is throughout on a daily basis, you will observe tropical evergreen forest with dense canopy cover and very large biodiversity. Flora and fauna is significantly rich. You will find in these areas particularly a lot of insect population. Reptilian population will be very, very high in these areas. And in these areas, basically, you would also come across the situation where, for example, large herbivores won't be present, elephants, etc. They won't be present, but you will have the herbivore species in the form of the monkeys, the apes, the chimpanzees, etc. So the arboreal species and the birds, their population will also be very high. Because these are the regions generally around the region of equator, so you will observe almost an equal day length. The length of day in these areas, length of day is and night is almost equal because we are talking about equatorial regions. Equatorial areas. So, for example, in the region of Peru, Amazon Basin, Congo River Basin, Philippines, Indonesia, in all these areas, this is what is also this rainforest in the region of Amazon. This is what is also referred to as selvas. Okay, that is a portion also referred to as selvas. So that is your AF. F means rains throughout the year, continuous rains throughout the year. Then we come across AM, that is rainfall during the monsoon months. That is what is regarded as AM type of climate. So annual rainfall is similar to that of AF, but here Precipitation occurs only within the 7 to 9 warmest months, that is during the monsoon season mostly. Okay, during rest of the year there is less precipitation, winter is generally drier. Okay, so here you would observe that in the peak of the summer the rainfall is distributed. So here if you observe the climatic type in this case, observe all that rainfall is concentrated in the month of the monsoon. This is for Mangalore, right? Now in Mangalore you will experience this, that the amount of rainfall is very high during the rainy season, that is the monsoon month. Observe the amount of rain received per month during the monsoon, close to around 100 centimeter in 1 month itself. Whereas in the AF type, per month, you would be receiving only close to around 25 to 30 centimeter. So think about it. The amount of rainfall received in the AM climate overall when taken for an year, it is almost equivalent to AF. But then all the rainfall is concentrated within the span of 3 to 4 months. That is the difference. And for the rest of the year, the amount of rainfall is significantly lesser, quite significantly lesser. So here, in these areas, you find the presence of monsoonal forest, what is also referred to as tropical deciduous forest, which is also referred to as monsoonal forest. Okay. They are also referred to as monsoonal forests. So, why? Because during the dry season in these areas, you will experience that the trees, in order to conserve themselves, they will shed their leaves. Because the trees regularly through the leaves, they continue to lose water into the atmosphere regularly through the leaves. Why? Due to the process of transpiration. Now, that is a process which is regular and continuous. But then, as soon as the rainfall comes in, again these trees will start regrowing the leaves. So, in order to conserve themselves during the dry season, the trees will shed their leaves. So, trees shed their leaves during dry season. Again, regained as soon as you have availability of moisture. Okay, so that is why during the dry season this forest will give you almost a deserted look, as if everything is burnt, everything is dried out. But as soon as the rains come, entire region will be covered under green blanket of almost, right? Now AM type of climate again is experienced in the tropical areas across the world, and basically wherever closer to the water bodies you have the reversal of the winds being able to bring rainfall in those areas, and in the vicinity of AF you will come across AM as well. Now, then you have the tropical savanna, AW. W means winter is dry, right? So little amount of rainfall received, very little amount of rainfall received, but is received only during the summer months. So here, very short span of rains. Very short span of rainy season. Rains received during summers. Okay, so that is basically your AW. And the image in itself will tell you. Here, you will find the presence of grasses. You will not find very dense tree cover. Rather, you'll find the presence of grasses. And by taking a look at the image also, as I have always told you, you can end up extracting much more amount of information by looking at the images rather than by reading the text. So if you take a serious look at this image once again, you will observe that the percentage of trees, they are very, very less. This region is dominated by grasses through and through, right? But these grasses also give you the brownish appearance, the dried appearance. So that means the total amount of rainfall is very less. Okay. And also, moisture, the lack of moisture means larger trees cannot sustain, and you have large open spaces. So that means larger herbivores will be in existence in these areas. And when we say larger herbivores, we basically are referring to the various different types of herbivores, such as elephant population, such as when you talk about, let's suppose, zebras, giraffe, all of them you can find in these areas. Okay, so here you will find carnivore population also. Now, when the dry spell is very long, as is the case, now immediately after that, sometimes what you experience is that due to thunder and lightning before the rainfall, these regions, they very frequently catch fire. So wildfire and forest fire events, not forest because you don't have forest here, wildfire events are very common in these areas. Okay, and wildfires, they will reduce the grasses to the ashes, and again when the moisture comes in, the roots will regrow into fresh grasses. Okay, so this is the kind of climatic condition experienced, and this is for Brazil. So obviously summer season is in the later months. So in the summer season you will experience rainfall, but not very high, less amount of rainfall, little amount of rainfall. Okay, so if you take a look at the features of them, but before that, where they are spread over, so these grasses, they are spread across various different parts. So here you will observe it in the region of Campos in Brazil, Llanos in Venezuela, right? Then the region of Sahel, the Sahel region and the Serengeti region in Africa, right? In India also, as I told you, in the regions of Karnataka, Tamil Nadu, in the regions of Telangana, Maharashtra, some portions of Madhya Pradesh also, you'll find these tropical savanna kind of conditions to exist. In the northern portion of Australia also, you'll find this to be in existence. So here, the wet season basically is shorter and the dry season is very prolonged, and temperature is high throughout the year, and the diurnal range of temperature, what do we mean by diurnal range of temperature? The variation of temperature between day and night. So when you hear about the term diurnal range of temperature, we basically refer about temperature variation between day and night. So that temperature variation, where the days are very hot and the nights become very cold, when is it that you will experience it the most? During the dry season. It is during the dry season when, due to the dry lapse rate, the nighttime temperature will be very, very low. It will be significantly colder. So temperature is high throughout the year. Diurnal ranges of the temperature are greatest in the dry season. Okay. Now, tall to short continuous grasslands with scattered trees is something that you observe. Sometimes deciduous forest, but generally grasses is what you experience. And wildfire events are very common in these grasses. Due to dry climate, wildfire events are quite common. But the trees are unable to grow because of lack of enough moisture. So example, northern and eastern India, Llanos of Venezuela, Campos of Brazil, western central Africa in the Sahel region. Sahel region is actually a transition between the Sahara Desert to the north and the rainforest immediately to the south in the region of Congo. So in between, in the entire area around Nigeria and so on, you have large extent of this tropical grassland. That is the savanna grassland. Okay. Now, then the B type. B type is the dry climate. Dry climate means there is an overall deficiency of moisture. Now, when is it that you will have deficiency of moisture? When the amount of moisture received, when the amount of rainfall received is always going to be less as compared to the amount of water which is lost or the moisture lost due to evaporation. So, rate of evaporation in this case is always going to be greater than rate of precipitation. Always. So that will lead to deficiency of moisture. Okay. Now here, generally the plants or the animals that you find in this region, they are well known to be adapting to this kind of drier condition. Plants growing in these areas, they are referred to as xerophytes. And they have adapted themselves to suit this area. So that is why they don't have leaves. The plants of these regions, they don't have leaves. Rather, they have thorns. And the green pigment in the plants, that is concentrated into the stem. And it is the stem which manufactures the food. And that is where you will find the stem also stores the food. So, for example, cacti and cactus in general. Right? Now, even in the case of B type, you can have hot deserts, you can have cold deserts, you can have semi-arid areas, and you can have absolute deserts. Right? So that is why here B type is further subclassified into BW, capital W, and BS. BW represents deserts. BS is much more in the mid latitude areas. This represents semi-arid regions. Semi-arid areas. Okay. Now, so dry climates are classified by very low rainfall that is not at all adequate for the growth of plants, and large diurnal temperature range means what? Daytime temperature is very high, but because it is a desert area, the air above it is going to be very dry. Nighttime temperature is going to be extremely and abysmally low. So highest daytime temperature, nighttime temperature is very low. Temperature is very low. Okay. Now, evaporation and transpiration, they end up playing a significantly greater role in shaping the vegetative state than the temperature, because evaporation is much more consistent and is much more prominent. So evaporation and transpiration, what is together referred to as evapotranspiration, leads to a lot of loss of moisture from the ground, and the species have to basically adapt themselves accordingly. Now here also, when we talk about BW, so this is basically the classification of the desertified areas. Now here also you have a further classification into BWH, small h, and BWK, small k. H here represents hot deserts. Right? Average annual temperature, is greater than 18 degrees Celsius. Whereas BWK represents cold deserts, where average annual temperature is less than 18 degrees Celsius. So that is how even the deserts get classified into various different types. So here, if you observe this, then BW, it is a true desert climate. It spans and covers close to around 12% of the Earth's total land. So significant aerial spread is observed. Now, xerophytic vegetation usually grows here. Now, here, these are the areas which are generally deserts because of them lying either in the subtropical high pressure belt, right, or lack of any orographic factor which can cause immediate rainfall. So, why is it that you have these deserts? So, deserts in general, because of negligible rainfall, rains due to subtropical high pressure or regions lacking orographic barrier to the winds, or you can have a situation where prevalent winds are offshore or continental. So only these conditions virtually mean that there can be the occurrence or creation of a desert. But depending upon where that desert is, you do have the existence of both hot desert as well as the cold desert. So when you have the letter H attached, that represents hot desert, average annual temperature higher than 18. And then you have K, cold desert, which is in mid latitudinal areas. In the terms of mid latitudes, that is in further higher up in terms of latitudes from the H area. So for example, when we talk about Atacama Desert in South America, when we talk about Gobi Desert in Mongolia, so these are situated in middle latitudes. Middle latitudes, somewhere in the range of 40 degrees, 40, 50 degrees. That is where these would be generally located. Okay. Now, desert climate here, indicative of Tindouf in Algeria. Here, observe very low relative humidity, irregular, unreliable rainfall, highest percentage of sunshine, large diurnal temperature. So, these are the common features. Anything that you would generally imagine with a desert, you experience it in BW. Now, BS. BS represents semi-arid. Semi-arid means that you will have the presence of certain grasses, but that too will be very conditional. You will have some amount of rains which will be received during certain parts of the year, but you will have very conditional presence of grasses in case, let's suppose, in these areas you have a extra tropical cyclone or an extra tropical depression moving across a front or a frontal formation in general. That might cause sporadic or distributed amount of rainfall, but rainfall is not going to be a common phenomena through and through. So spans about 14% of the earth and makes up the grassland type. Receive more rainfall than their BW counterparts because of the mid-latitude cyclones, that is the extratropical ones, and intertropical convergence in very rare occurrences, but mostly because of mid-latitude cyclone and frontal formation. Frontal rains are received. Frontal rainfall is received. Okay. Now, this is also these grasses. They are also in Asia. They are referred to as steppes, right? And when you come to these mid latitudes, you have these such kind of grasses which are spread over almost in the entirety of the world. and all of them will have their different names associated. So steppes are something that you observe in the region of Central Asia. In the region of North America, you have the temperate grasses, which are referred to as by the name prairies. In the region of South America, around Argentina also, you have the presence of these grasses, what is referred to as pampas. Then in the region of South Africa, you have the presence of grasses, temperate grasses. They are referred to by the name veld. Then in the region of Australia, the grasses, they are named as the downs. And then in New Zealand, they are referred to as by the name Canterbury. So when you talk about the temperate grasses, I will give you the list of it. Try to locate it on the map. So here, temperate grasses. Okay. So in Central Asia, you have steppes. Then in North America, you come across prairies. In South America, you come across pampas around Argentina. In South Africa, you come across veld. Then in Australia, you come across downs. In New Zealand, you come across Canterbury. Okay. So that is how you have the presence of these grasses, temperate grasses, across the entirety of the world. Now then, you also have BWK and BSK. These are the colder areas, mid-latitude deserts and the steppes, which are in presence beyond the tropics, in the temperate regions mostly. Now, here, when we talk about cold deserts, for example, Gobi Desert, if you observe the presence of Gobi Desert and the location of Gobi Desert, I want you to observe this. This is your Gobi Desert spread of it. Okay, that is the spread of Gobi Desert. Now, why that region is a desert? So if you take a closer look, that region is very far away from the source of moisture, very, very far away. The only way in which this region could have received rainfall would have been if there would have been a mountain system here or here, and it would have provided an obstruction to the wind. But that is not the case. These areas, they lie on the leeward side of the mountains as well. So obviously, these are going to remain as drier. These are significantly drier in existence. So that is why here these climatic types are dry because of extreme continentality and the effect of higher elevations. They have a greater height. So that also means lesser rainfall in many of the regions. Being located at the center of a continent limits the amount of moisture which reaches these areas. Without the moisture, precipitation cannot occur at all. And the presence of mountains upwind of these climates means that you have a rain shadow effect, and the leeward side of these mountains experience these conditions. However, when we talk about BS, that is BSK, that is, for example, the some amount of semi-arid grasses that you will find. So again, those grasses are in existence purely because of the frontal rains which are received. Major expanse of mid-latitude deserts can be found to the east of Caspian Sea, north of Himalayas in the western United States, and east of Andes in the narrow region of South America, the region around Altiplano in South America. Mid-latitude deserts have a great range of both daily and annual temperature. Because of dry condition, the lapse rate is also significantly higher. Okay. Now we come to C type of climate, which is the mid-latitude climate, which is also referred to as temperate climate. Winter is not very cold. Summer is not very hot either. Okay, that is your C type of climate. So here generally experienced across the coastlines in mid latitudes, where you will have the influence of rainfall etc also received in those regions. So that is where you experience it. So hot and humid summers and mild winters extending between 30 to 50-degree latitude northwards and southwards from the region of equator. And these regions are typically the eastern and the western extremes of each continent. That means closer to the coastal areas, so that you have the intervention in forms of onshore winds. So receives rainfall with the help of onshore winds. Receives rains through onshore winds. Okay. Now, sometimes summer months may feature convective thunderstorms and winter months mid latitude cyclones, because that is the region where they lie. So, mid latitude cyclones will also be frequently observed in these areas. Now, here, if you observe the further classification of the C type, these are the areas where you experience the C type. So, for example, here you will experience this around the region of Mediterranean. Here you will experience this in the region of Western Europe and this area also, UK, right? In these areas, you will experience it. So here, observe, all of them are at the extremities of the margins, continental margins, that is at the boundary of the continent and ocean. This is what is referred to as the China type. This is what is referred to as British type of climate. This is what is referred to as Mediterranean type of climate. This is what is referred to as Gulf type, because it is around the Gulf of Mexico. And these are what are referred to as natal type, because of the similarity of climatic condition as experienced in the natal region of South America. So, of the natal region of South Africa, rather, this is what is your natal type of climate. Okay. So, that is how you have the naming of them, depending upon in which region this kind of climatic conditions are generally experienced. Now, here, the further subclassification of C type: CFA, humid subtropical; CFB, this is what is referred to as the British type. So CFB means temperature is not very high, right? It is slightly colder, but rainfall throughout the year. Why? Because take a look at the location of Britain. It is closer to the sea. It is in fact surrounded by water body from all sides. So that means there will be significant amount of rainfall which will be caused through the year by the onshore winds. And then you have CS, that is summer dry, right? So rains only during winter in this Mediterranean type of climate, rainfall only during winter. Only during winter. Okay. And then CW type, winter is dry. That is the China type, what is experienced in the region of eastern China. So rains only during summer. Why is it that it will rain only during summer in China? Because the ITCZ, eastern China, we are talking about, ITCZ passes through that region during the summer. So rains only in summer season. Understand, guys, once again, for this, for your examination, you don't need to learn the codes. You just need to understand what is the temperature experience or what is the climatic conditions experienced in the British type, what are the climatic conditions experienced in the Mediterranean type, what are the climatic conditions experienced in China type. That's it. That's all that you need to understand. You don't need to get into what is CFA, CFB, etc. UPSC has never asked this for a long period of time. So UPSC is not going to ask that in any time in the future. So that is something accordingly you can prepare yourself. Accordingly, you can arm yourself. Okay. Now, here, let us take a look at each one of them one by one, starting with CFA, or the humid subtropical type. So it lies on the eastern part, so the Gulf climate that we talked about. So eastern part of the continent in subtropical latitudes, no dry season. Why? Because here, so close to the sea, very proximal area close to the sea, you receive rainfall due to the unstable air masses in that region. So rains are received through the year. Examples are eastern United States of America, southern and eastern China, southern Japan, northeastern Argentina. These are the areas where you experience this. Annual range of precipitation observed is only around 75 to 100 centimeter. But even this much precipitation is more than enough. In India, if you would have had this much amount of precipitation, it would basically be very, very dry, significantly dry. But in temperate areas, this much precipitation is enough. Why? Because the rate of evaporation is less. That is why even this much precipitation is sufficient. Here you have the factor as indicated in Memphis, the climatic conditions experienced in Memphis, Tennessee. So you would observe that basically it rains throughout the year, right? And during the summer season, the temperature does rise up. But during the winter season, the temperature can dip almost around 5 to 6, as we experience in northern part of our country. The only difference is in the northern part of our country, we do not experience rainfall throughout the year because that is not closer to the coastline. Okay. Now, that was your CFA. Now, when we talk about CFB, CFA is experienced here in this area. In this area, here you will experience CFA. Then we have CFB, which is basically marine west coast climate. This is also the British type of climate, which is northwards to the Mediterranean. Remember, we talked about Mediterranean type of climate closer in the surrounding and the vicinity of the Mediterranean Sea. So this is basically poleward to the Mediterranean climate on the west coast of the continent. Now, the main areas are northwestern Europe, west coast of North America, north of California, southern Chile, southern Australia. Rainfall is received throughout the year. How is it possible that a region can receive rainfall throughout the year? If the winds are onshore continuously. So, in the temperate regions, which are the wind systems which are in existence? You will only have the westerlies in existence. Westerlies will be the prominent wind systems in existence. So, that is why here you will have wind systems basically being onshore throughout the year. And which wind are we talking about? Prevalence of westerlies. That is something which you will consistently be observing. Now, due to marine influence, the temperature is moderate and the winter is warmer as compared to the regions in this latitude. Because remember, we had talked about the fact that whenever humidity is very high, heat retained is also significant. So, moist areas are comparatively warmer and hotter. So, that is why here the temperature is moderate. So, in the interior continental areas at the same latitude, the climatic condition will be extreme, but here it is moderate. So annual range of precipitation varies between 50 to 250 centimeter, and here winters are milder. They come with heavy rainfall due to mid-latitude cyclones sometimes. Okay, so frontal formation is also observed in these particular areas. Now, this is your characteristics. So example observed in London, England, basically the amount of rainfall received is consistent through the year, right? And the temperature does increase or decrease, but because of marine influence, the rainfall is common, consistent, right? So areas of Western Europe, areas to the western part of North America, here also southern part, here also you will experience that. So in all these areas, you experience much more particularly the region of Western Europe. Then we have the Mediterranean or CS, where rainfall happens only during the winter. Summer season is dry. Why? Because during the summer season, around the region, you have the presence of subtropical high pressure belt. So it comes under the influence of subtropical high in summer, and during the winter, as the pressure belts they shift to the south. So if you take a look at this is the particular image of the latitudinal position here. So during the summer, this entire area, it comes under subtropical high pressure belt. But then during the winter, this pressure belt will shift to the south. So that means in this area, you will have the prevalence of westerlies now, and they will become onshore, and they have the capacity to bring rainfall. That is why this region will experience rainfall only during the winter months. Precipitation is low, but it is still sufficient given the latitude. But still, it is dry or not very, very high in general. So here, generally, you will find that orchards and growing of fruits are very common occurrences. That is a common factor here. So basically, precipitation is heaviest during the winters due to mid-latitude cyclones as well, and there's hardly any rainfall during the dry season. Okay, so growing fruits and orchards are the common economic activities. Okay, they are in general the common economic activities that you come across. Temperature in summer is around 25 degrees Celsius, and during winter it is around 10 degrees Celsius. So the temperature drops, but it still continues to remain around 10 degrees Celsius. So that is your Mediterranean type. And then you have the China type, CW. So here, during the summer, the ITCZ does lie or does come over that area. And that means it brings rainfall, right? So here, basically, it is dry in winter, hot in summer, rains are received during summer because the ITCZ passes very close to it. That is why in the region of ITCZ, you experience that convectional process and the convectional rainfall, which is accompanied along with that. Then you have the D type, which is basically again almost at a similar latitude as the C type, but it is significantly present in the interior of the continent. Some areas also across the coastline, for example, across Canada, if you observe, there in certain areas you will experience rainfall on a daily basis, right? So there also you have a very regular occurrence of rainfall, but in many of the areas you will experience rainfall distributed or dispersed. Overall precipitation is never going to be very high in these areas, but temperature during the winters will be very, very low. So as you can see, these are the regions of high latitudes, very high latitudinal position. So the cold snow forests occur in large continental areas in the northern hemisphere between 40 to 70 degree north latitude. Why not in southern hemisphere? Why only in northern hemisphere? Because in southern hemisphere, you don't have that continuity of land mass in the region around higher latitudes. So only it will be found to be present, to be predominant in the region of northern hemisphere. Summers are typically warm, but here warm means 5-10 degrees Celsius, not warm like India. So summers are typically warm, but can also be cold, while the winters are cold. During the summer months, average temperatures climb above 10 degrees Celsius in certain cases, while in colder months, it can easily be less than -3, -5, and so on. So here also you have a general classification as DF, DW, and DS. And severity of winter is much more pronounced, obviously, as you go to the interior and further to the higher latitude. Now, cold climate with humid winters. So for example, winters are cold and snowy. The frost free season is very short. That means it is almost raining through, or it is almost having precipitation here mostly is in the form of snow. Rainfall is received in very few months, but mostly you have snowfall which is received. Okay, annual ranges of temperature are very large, and winters keep on getting much more severe. Example, you have Winnipeg in Canada, where if you observe the temperature during the winter, it can be -10, -20 degrees Celsius almost. Okay, so that is the temperature that you experience. So basically, this is the characteristic of DF type of climate. Now DW, so here cold climate with dry winters, northeastern Asia, in the region around Siberia. So there the winter anticyclonic conditions develop. Remember, I told you about the Siberian region. Siberian region, if you recall the portion of the pressure belt systems, we had seen the presence of Siberian high, right? So that Siberian high creates that high pressure, means no precipitation. So that is your winter anticyclone, and it weakens during the summer, sets in monsoon like reversal of wind, but not exact and true reversal that you experience in India. Precipitation occurs only and mostly in summer, and annual precipitation ranges 12 to 15 centimeter. Then you have the last type, that is the polar type, experienced in the polar region. This also has got further classification into EF and ET. So here, polar climates, polewards beyond 70-degree latitude, temperatures are usually low all through the year. Warmest months see temperature less than 10 degrees Celsius. So in many of the areas, it is frozen almost throughout the year. So you have ET, that is the tundra type, where very few days a year you will experience the frost free condition, ice free conditions of the topsoil, but the lower regions are permanently frozen. So these are the regions of permafrost, right? So here, this is the region of permafrost where the subsoil is permanently frozen. So here you have some mosses, lichens, etc., which will be observed to be growing during the dry season, or rather the warmer season. And during summer, they have longer duration of daylight, which can extend for almost half a day and even beyond. So this is your E-type or ET in general. And then you have EF. EF represents the region which is permanently frozen. So surface is permanently covered in ice or snow. So for example, interior of Greenland, for example, the region around Antarctica, these are permanently frozen throughout the year. So even in summer, the temperature is below the freezing point. Almost negligible precipitation is received in this area because no evaporation almost happens, no evaporation is observed. So precipitation received is negligible. Okay. Example, you can see McMurdo Station in Antarctica. So while the winter temperature can go to the range of -30, -35, even the summer temperatures are in the range of -5. Okay. Now, that brings us to the end of this particular unit, this particular chapter. Now we have questions associated with climatology. So we'll take up those questions associated with climatology, and then we will move over to oceanography. So read these questions carefully and let us know what the answers are. The seasonal reversal of wind is the typical characteristic of seasonal reversal of wind is the typical characteristic of equatorial climate, Mediterranean climate, monsoon climate, all the above. Even though I don't think you need 30 seconds for this, but still. Correct, Abhishek. Good. So these type of questions will be asked, which will be easier to tackle. Devi, correct. Good. Majority of you have given the correct answer. So the answer is monsoon climate. It is in the monsoon climate where you will experience or come through the seasonal reversal of climatic condition. Then consider the following statements. One, this is two, and this is A, B, C, D. I hope that much sense you can apply. Consider the following statements. Take a look at these statements, read these statements carefully, and let me know. Winds which blow between 30 north and 60 south latitude throughout the year are known as westerlies. Moist air masses that cause winter rains in northwestern region of India are a part of westerlies. Which of the statements given above is or are correct? Good. Again, majority of you have given the correct answer. So the first statement is incorrect because you don't have any wind system which blows between 30° north and 60° south. Either the winds will blow between 30° north and 60° north, or 30° south and 60° south. Okay, between 30° to 60 north to 60° south, you don't have any wind system. So the first statement is incorrect. Second statement, moist air masses that cause winter rains in the northwestern, that is the western disturbances, they are brought forward by the westerlies. So this is correct. Second statement is going to be correct. Now, which of the following is the characteristic climate of the tropical savanna region? Rainfall throughout the year, rainfall in winter only, an extremely short dry season, a definite dry and wet season. Which of them? Good, Parshuram. Gaurav, correct. Good. So here, the correct answer is definite wet and dry season. Okay. Now, consider the following statements. Duration of monsoon decreases from southern India to northern India. Amount of annual rainfall in the northern plains of India, amount of annual rainfall in the northern plains decreases from east to west. Which of them are correct? Good. Again, 50% of you have given the correct answer. So duration of monsoon decreases from southern India to northern India. So monsoon reaches last in the northwestern part and withdraws first from northwestern. So duration of monsoon in the northern India is minimal. It is maximum when we come to southern India. So this is correct. Amount of rainfall reduces from east to west as you are moving away from the source of moisture. This is also correct. So the correct answer is going to be C. That is both 1 and 2. Then during a thunderstorm, the thunder in the skies is produced by meeting of cumulonimbus clouds in the sky, lightning that separates the nimbus clouds, violent upward movement of air and water particles. Which of them produces thunder? You know the process of creation of thunder. Apply your logic. Good, Abhishek. Parshuram, correct. Very good. 57% of you have given the correct answer in this case. So the correct answer is thunder is produced by what process? Sudden and violent explosive expansion of air, right? Because of lightning, the heat is produced, which is so high that you have a sudden and violent expansion of air. None of these produces thunder. Okay? And seasonal reversal of winds is something we have seen. Now, each day is more or less the same. The morning is clear and bright with a sea breeze. As the sun climbs high in the sky, heat mounts up, dark clouds form, then rain comes with thunder and lightning. But the rain is over soon. Which of the following regions is described in the above passage? Correct, Shahid. No, Gaurav. So equal number of people have given the answer. See, understand this. Each day, sun climbs high in the sky. Heat mounts up. So when there is heating, dark clouds form. And when you have dark clouds, rains come on a daily basis. Each day, rains come with thunder and lightning. There is only one type of climate where you will receive rainfall on a daily basis with thunder and lightning, and that is equatorial type of climate. Okay, please don't commit mistakes in these types. These are very low hanging fruits which you should not ignore. Why are dewdrops not formed on a cloudy night? Clouds absorb the radiation released from the earth's surface. Clouds reflect back the earth's radiation. The Earth's surface would have lower temperature on cloudy nights. Clouds deflect the blowing wind to the ground level. No, Parshuram. Apply your logic. You will get it correct. Shahid, correct. Gaurav, no. Satish, correct. So majority of you have given the incorrect answer. And if you think about it, what is the question? Dewdrops are not formed on a cloudy night. So the reason has to explain why dewdrops are not formed. Now, most of you have given the answer C. Earth's surface would have low temperature on cloudy nights. So in case the Earth's surface has low temperature, why won't the dewdrops get created? Dewdrops will be formed in that case much more easily, isn't it? So C is absolutely incorrect. You have to find the answer of why they are not formed. So the answer is clouds reflect back the Earth's radiation, thereby providing for the heating. And that is why, because the heating is there, condensation cannot happen. So answer is B. Okay. So that is where we come to an end with climatology and we initiate the discussion for oceanography. Before that, do one thing, take a 10 minutes break, recharge yourself, and then recalibrate yourself, and we will start with the portion of oceanography. Okay? Break. Okay, a confirmation about the audio, please. If the audio is working clear and fine, thank you. So now we come to the final module of your physical or world geography, whichever portion you want to consider. That is the portion of oceanography. Now, oceanography presents you with a kind of an easy scope to score significantly good in your examination, be it for your prelims and mains. Because here, when we talk about the portions from oceanography or the questions that are asked from oceanography, they are generally belonging to the easier category and they are very direct. In climatology, you still have the scope for certain complications in the concepts which can be arranged while asking questions, but not so is the case with oceanography. So here, when we talk about oceanography, we will follow a certain methodology in our coverage of the syllabus. First of all, just like the case with geomorphology, climatology as well, just like that, first of all, we shall be covering the basics in terms of what are the ocean bottoms appearing to look like, what are they constituted of, the features of the ocean bottom. Then we are going to study the physical properties of ocean water, where we shall make ourselves familiar with the factors of ocean temperature, ocean salinity. These are the factors which we will be familiarized with. And then after that, we will be talking about salinity conditions in detail, how they will influence salinity and temperature, how they can influence the density of oceanic water, the circulations which are induced. After that, we are going to transition to the movement experienced in the oceanic water, where we will be observing the occurrence of waves, tides. Why is it that the tides come into existence? What do we understand by ocean currents? These are the factors that we are going to study in detail. Okay, so when we talk about it, the syllabus of it or the coverage of it, eventually after that we will have a separate module about the coral reefs also. But here we are going to cover portions of ocean bottom relief, then physical properties of oceanic water, that is temperature, and salinity. We are going to cover about thermohaline circulation, haline circulations, then movement in oceanic water, or rather than that, waves and tides, then ocean currents. Global conveyor belt, okay? These are the areas that we are going to cover. Now, many of these areas are relevant both for your prelims as well as mains. So when we take a look at the regions where questions in the prelims are frequented from, so in prelims, you get questions about tides, ocean currents, okay? Also, temperature and salinity of oceanic water. Okay, variation of them. How do they vary? Now, This is the region where you generally get the questions from in the prelims. In the mains, questions have been asked previously from the regions of bottom relief, physical properties, then thermohaline circulation, and AMOC, ocean currents. Okay. These are the areas from where questions can be expected to be asked and can be expected to be asked in a repetitive manner, both in the prelims as well as mains. For example, from ocean currents, UPSC has repeated the same question which it has asked in the mains examination multiple times. It has not only asked it once, it has asked it multiple times. So that tells you that the same question is repeated in the mains examination. At least the pattern of it is repeated quite often. Now, here, let us initiate the discussion. Yesterday, earthquake happened in Nepal. Is it important for exam? Frame a question. Do one thing. Suppose you are the examiner for UPSC. What is the question that you would frame from the area of earthquake in Nepal? Please let me know. Take your time. Frame the question. Reason. Okay. What would be the question like? That why is it so next year you are going to appear for the mains exam, suppose. So the question would be that why is it that on in October 2023, why is it that we experienced earthquake in Nepal? Will that be the question? Or will the question be like, in October 2023 we experienced earthquake in Afghanistan and Nepal as well, and then in November we experienced it in October, by the way, you experienced earthquake in Delhi also. So here, reasons for earthquake can always be asked. But reason why Nepal earthquake has occurred, reason why Afghanistan earthquake has occurred, why the region of Delhi earthquake, again, I will tell you, take full freedom. Think about it. Give me a question within the next 10 minutes, frame a question from this, get back to me. That what kind of questions can be created from here, right? That an earthquake has occurred in Nepal, Afghanistan, Assam, Delhi, in the region of Libya also earthquake happened, Morocco also earthquake happened. So how will you frame the question? Will you frame a question in the way that name all the regions which experienced earthquake last year, or along with the reasons? No. Basic questions about the reasons can always be asked, but never get excited with these events that, yesterday there was this event, so UPSC will ask about that event next year in the mains exam. Next year mains examination supposed to be conducted in September and October. So use your logic. Okay. Now, so Parshuram, is it understood? Yeah. Elaborate the reason behind them? No. See, they will ask Gaurav. No, that kind of a question is never asked. UPSC will ask you a question that talk about the global distribution of the earthquakes and describe the reason. Or the Himalayan region experiences a lot of earthquakes. Explain the reason. Or the region of Afghanistan all the way to Himalayas experiences a lot of earthquakes. What is the reason? So these kinds of questions, not why in Nepal, where was the epicenter. I have seen students trying to rote learn the epicenter of each earthquake. Nobody is going to ask you that. It is just for your own self-satisfaction that I'm working towards the examination that makes you learn these things. But that is not for the purpose or the benefit of any of the purposes. Okay? I hope you understand the larger pattern here. Now, we come to the portion of oceans. Now, planet Earth is referred to as the blue planet precisely because of the fact that around 70% of the surface of the planet is covered under oceans. Now, these oceans, for a long period of time, they were supposed to be almost as flat on the bottom as on the surface because we did not know any better. Even today, while man has managed to reach the moon, man has managed to send instruments and spacecrafts to Mars, to the sun, but we have not managed to explore the ocean bottoms. The ocean bottom relief is nothing but a secret or a mystery for all of us. Now, these oceans, they not only sustain a wide variety of life, they have played a significantly vital role in shaping biodiversity and shaping the evolution of life pattern around us as well. So that is something you experience as a role of oceans. They are climate regulators. They are carbon dioxide guzzlers. And they are providers of income, food, and support to all the world. Now, as we have already discussed in our discussion for geomorphology, for a long period of time it was understood, or what was believed was, that just like the ocean surface is flat and plain, or appears to be flattish and plain, similarly the ocean bottom would also be flat and featureless. But the reality was very far away. Reality basically was understood to us only after explorations began to happen after Second World War. That is when we came across myriad types of varieties of ocean bottom. For even after that, if you consider the resolution in terms of when you map an area, there is certain areas when you map, so you get a greater resolution. That means greater details. So you'd be surprised to know that even today, we have a better resolution images and a better resolution pictures which are available for the Mars, for the lunar surface, but then for the ocean bottom, we don't have such resolution or good resolution pictures available because we have not even managed to map it out. Many areas that you see, for example, in these regions of the Pacific, they have not yet been mapped out. So it still holds a lot of mystery for all of us. It still shapes the planet that we live upon. So that is why study of ocean becomes very pertinent, becomes very, very important at the same time. So when we talk about the ocean relief, we talk about the bottom features, the topographical bottom features in the oceanic areas. Okay, so here, if you take a look at this map, from your childhood days, at least whenever your school teacher would have asked you to do the map work in class 4th, 5th, 6th, 7th, whenever you would have had a map in your hand or an atlas in your hand, you would always have done and understood the same thing, that the blue regions represent the oceans, the blue covered areas represent the oceanic areas, isn't it? Now, but these blue regions, they are not uniform blue. You would observe certain areas very bright blue, certain areas very dark blue, which in itself tells you that at the ocean bottom you have topographical features of varying types and varying depths. Different types of features are in existence. So here, let us first of all study these ocean relief features. So, land under the waters of the ocean exhibits complex and varied features. These are formed by the factors of tectonic plate movement, volcanic activities, or the process of erosion and deposition. Right? So, for example, when we talk about, let's suppose, tectonic. So, ocean bottom relief. So, for example, let's suppose we talk about the various different types of ocean bottom relief. So, before we classify it, I hope we are aware, we have read about seamounts. What are seamounts? Seamounts are basically underwater mountains that you have. Underwater mountains, isn't it? So, if let's suppose you have the oceanic water to a great depth, So you have an underwater mountain of sorts, that is a seamount. Now, as long as the volcanic eruption or the activity of mountain building continues, the height of the seamount will continue to increase. But eventually, a situation might come when the seamount's height won't increase any further. You have few of the seamounts, by the way, which are even higher than the Mount Everest, in the sense that they rise from the ocean bottom and they cover the entirety of the ocean depth, and they rise above the ocean surface as well. And above the ocean surface, they will have a height of around 2,000, 3,000 meters. So if they would have been in the region of Mount Everest, they would have been very tall. But suppose the increase in height of these seamounts that comes to a halt, then what happens? In that situation, here, basically, once the seamounts and their heights don't increase any further, then they undergo erosion. They undergo the process of erosion. And these seamounts, once they get eroded, you have the presence of almost flat tableland like structures. And these are referred to as goyards. So goyards get created when seamounts are eroded from top by oceanic water, because oceanic water is perpetually in motion, isn't it? It is perpetually and continuously in motion. Now, the types of land, the different types of features on the ocean bottom, if you will observe, they can be classified into the fact that they can be tectonic in nature, volcanic in nature, right, or erosional and depositional in nature. So when we talk about tectonic basically, what kind of features do you have underneath the oceans which can be tectonic in nature? Seamounts, volcanic in origin, right? You can have mid-oceanic ridges as well. So here we can talk about mid-oceanic ridges. Mid-oceanic ridges, however, can also be considered in the portion of volcanic. So let us leave that for the portion of oceanic. Here, let us talk about oceanic trenches. Oceanic trenches. They are created because of tectonic activities, isn't it? Then you have volcanic processes leading to creation of mid-oceanic ridges. Seamounts, goyards, right? In all these, you have the volcanic processes which come into play, and then erosional and depositional processes also. So, for example, here you have the creation of continental shelf, continental slope, then submarine canyons, right? All these basically deep sea plains. These basically are erosional and depositional features. So, in a way, we can have the understanding that any of the ocean bottom relief feature that you come across, they are a sum product of the geomorphic processes in general. Any of the various different types of relief features that you come across, they are some product of the geomorphic processes. It is either by tectonic, volcanic, or erosional and depositional processes that they come into existence. So here, when we go for the division of the ocean floor, the ocean floor broadly can be divided into four major categories. You have continental shelf, continental slope, deep sea plain, and oceanic deeps, which is also referred to as oceanic trenches. Oceanic trenches. Okay. Now, these are your major divisions of the ocean floor. Other than that, you also have certain minor divisions, for example, minor factors such as ridges, hills, seamounts, gallards, trenches, canyons, etc. These are also present, but majorly, ocean floor is consisted of these particular features. So let us take a look at these features in brief detail. So when we talk about these particular features, you have to understand it is not the case that as soon as the land ends, the water goes very, very deep and immediately it becomes very, very deeper. No, that is not what happens. Basically, as the land comes to an end, as you can observe, the region extends further. Okay, almost with a kind of a similar slope. And then after that, so this is the region which is referred to as the region of continental shelf area. Now, that continental shelf comes to an end at a region which we refer to as shelf break. This is the area or this entire region that you see, that is your shelf break. Now, it is this continental shelf, which is not very deep, obviously. It is around 60 meters to sometimes even 300 meters deep, but not more than that. That means here you will have availability of sunlight. And wherever you have availability of sunlight, means obviously biodiversity will be very, very high. You will have a lot of plants, marine plants, aquatic plants, which will be in existence. A lot of animals, etc., will also be in existence. So this shelf region is very rich in biodiversity. Okay, these continental shelves basically represent only 10%, less than 10% of the area of all the oceans across the world. If you consider all the oceans across the world, these shelf regions represent an area of less than 10%. But then they house more than 90% of the oceanic biodiversity. Okay, so the shelf region has covers less than 10% of oceans, but has more than 90% of biodiversity. This is an area that is a continental shelf where obviously the species are present in very large numbers. So in this area, you will also find the presence of fossil fuel, that is crude oil and natural gas. How is it that crude oil is created? Remember, we have discussed about it in geomorphology also. The formation of petroleum and natural gas. How is it created? By the deposits of the marine animals. Just like coal is created by the deposit of vegetation, crude oil gets created by the deposit of marine species, marine animals. So those marine species and animals, not only do they get deposited, but on top of that, them there is so much amount of compression that it leads to existence or the formation of crude oil and petroleum and crude oil and natural gas. So even in India, in the region of the continental shelf, you will observe that there is significant amount of fossil fuel reserve, Bombay High, that is present in Arabian Sea. It is present in the continental shelf region. When we talk about the Krishna Godavari KG basin, that is also a source of oil. So that is again in the continental shelf region. So continental shelf region is very rich in terms of its resources, be it the economic resources, corals you will find there, be it the population of fishes will be very high in the shelf area, be it the fossil fuel, crude oil, natural gas, be it the biodiversity, ecosystem services, everything is prevalent in the region of continental shelf. The shelf ends at the shelf break. By the way, the extent of continental shelf is not consistent throughout. In certain areas, the continental shelf will be very wide. For example, in the region of Siberia, if you observe this map again, I want you to understand more from images. If you observe this map again, the light blue colors that you see closer to the continents, they are the shelf areas. So in these areas, for example, the shelf can extend up till around 1500 kilometers from the coastline. But observe this region. The shelf is almost absent. So the width or the extent of the continental shelf is dependent on the topographical feature of the coastline. So for example, let's suppose we talk about here a kind of a flattish land, let's suppose. Now, in that kind of flattish land, the shelf can extend for a large distance. But let's suppose closer to the coastline, you have the presence of a mountain. So obviously, the shelf won't be extensive enough. Right? So the shelf will be almost non-existent. So that is where the extent of the continental shelf in itself is dependent upon the topographical features. Observe here, this is the region around North Sea. I hope you can observe this on the map. This is the region around North Sea, continental shelf, very rich in oil. So this is the source of all the richness that is accrued to the Nordic nations, that is Norway, Sweden, Finland, etc. The reason why they are able to have such a good public infrastructure, free health services, etc. for all. Why is it so? Because of oil. So it is found in this area. In India, it is here that we find oil. Here we find some oil. Right? So that is the extent of shelf. Now, after this, suddenly you will experience that the slope increases. This is, or the gradient increases. This is what is continental slope. Here, the depth can go on up till around 3 kilometers from the sea surface. So, at the lower end of the continental slope, you won't be receiving or experiencing any amount of sunlight whatsoever. So here, as you go into the depth, basically the amount of pressure exerted from top, that also increases, temperature starts dropping, visibility is negligible. Then after that, here you have many of the deposits brought by the oceans and the seas. They get dropped and they get deposited in this region. That is the region of continental rise. So that is the area of the continental rise. So in the case of the rise, what happens? Imagine if this is the region of the shelf. Here you have the shelf break, the slope, that is, and then before getting into the deep sea plains, this is your portion of rise. Continental rise is not available everywhere. No. Continental rise is present only in certain cases, only in areas where these deposits are carried out. In all the other places, continental rise is not even present. Okay. So when you talk about the extent all the way from continental shelf to the region of continental rise, this entire extent of it, this is what is referred to as the continental margin. That is the margin of the continent. Okay. How does these continental shelf originated? Gaurav, basically, majority of these continental shelves are considered to be an extension of the landmass. the extension of the, for example, in the western portion of India, here, observe the continental shelf is very wide. It is basically because of, remember, we talked about the fact that Western Ghats is an escarpment, a significant portion of land underwent subsidence and is lying underneath that. So that has created shelf in many areas. In many areas, it is the depositional activities and the features of deposition which have created these continental shelf. So a variety of processes have come into existence and have created them. Okay. Now, here, the continental shelf is the extended margin of each continent occupied by relatively shallow seas and gulfs. Okay, it is the shallowest part of the ocean where the depth varies from 30-meter to as deep as even 600 meters, right? But still very much part of the visible area where the photic zone, because when we talk about the oceans, you have areas where the sunlight penetrates, or up till a particular depth the sunlight will be able to penetrate. That is your photic zone. And beyond a particular depth, sunlight is not able to penetrate. That is what is referred to as the aphotic zone. Okay. Now, here, the average width of the continental shelf is around 80 kilometers. In some cases, they are non-existent or marginal, like the coastline of Chile, west coast of Sumatra, in those areas. So generally, if you find a pattern, wherever in the coastal areas you find the existence of oceanic trench, that means there is some amount of subduction which is happening in that area. That means in those regions, you will never come across a wider continental shelf. Wherever there is that convergence, where you have folds on the sides, fold mountains created on the coast, and you have subsidence, which has created that trench like formation, you will not come across the wider continental shelf. It is largest around 1500 kilometers, example, Siberian shelf in the Arctic Ocean. It is very, very wide. Okay, generally, it ends at a very steep slope called the shelf break. It is a source of fossil fuel, that is crude oil and natural gas. Example, Bombay High, in Arabian Sea, right? And then similarly, even the Siberian shelf is very rich in oil. It is that is the area which is covered on top. The water is covered on top with the ice. But as the Arctic ice is melting, that is why all the various different countries are becoming increasingly interested in exploring the Arctic, in laying claim to the region of the Arctic. That is why Arctic is under so much amount of contention. As the various countries are struggling about the control of Arctic, what does China do? China announces, you know what? That is a polar Silk Route. So that is always going to be mine. So that is basically the oil-rich regions of the continental shelf and the opportunities that they offer. Now, continental shelf ends at the region of the shelf break, and beyond the shelf break, you do have the existence of what we refer to as continental slope. So, continental slope indicates the end of continents, the margin of continents, the continental margin in general, because not all the oceans will have the presence of continental rise, only few of them. Okay, so it indicates the end of the continents, connects continental shelf and the oceanic basins, and the depth of the slope region varies between 200 to 300 meters. Canyons and trenches are also to be observed here. Okay? Any doubts that you have till now? Any area where you have any kind of doubts? This is 3000 meter, 3000 meter. That is, from the surface, the depth of it can extend up till 3 kilometers. Okay? Because that is where the gradient is very high. Right? So let's do one thing. We will start the portion of submarine canyons later on, I want you to locate some places on the map. So do locate Hudson Bay, then do locate Isthmus of Kra, it is in Asia. Then Malacca Strait. Locate these, then we will cover it next week. That what do we understand by an isthmus and a strait? But if you locate it now, it will be beneficial for you. Then locate the Sinai Peninsula. Have you located earlier? In the case of the Israel and the war between Israel and Hamas, Sinai Peninsula again becomes important and relevant. Then do locate the region around Strait of Gibraltar. Then do locate the Atacama Desert. I think we have located Altiplano in South America. Then Campos in Brazil. Yes, Gaurav, correct. Llanos, Venezuela. Then after that, Lake Baikal. Okay. Then after that, locate. Okay, enough of South America. So do locate the Sahel region in Africa. Yes, correct, Gaurav. Then Selvas in Brazil. Okay, do locate these, and then we meet again and we will continue further. Okay, so that shall be all from my side for the weekend. So we meet again next weekend where we complete the portion of oceanography and we will initiate the discussion for Indian geography. We'll try to understand how to cover the Indian geography in the best possible manner. So thank you for a patient hearing through the weekend. We see each other again. We meet again next week. Till that, do take care of yourself. Goodbye. Thank you and good night.